Okay, and we should be live. Let me just check everything is all good. Are we all good on the sound? Let's have a look. Testing 1 2 1 2. Wait, let me just. Okay, we should be all good on the sound, and I think we're all functioning well. Okay, let's. Right, let's begin. Let me turn down the volume so I don't get any feedback. Okay, cool. So where were we? We were on forward declarations and definitions. So we learned last time that that a declaration is different to a definition. So a declaration is this: a forward declaration, i.e., when we have the main being above a definition such as add, and we want to and we want to call the definition we want to call the definition above the main, i.e., because the code runs sequentially, we need to make sure that main runs after, or main runs when calling add, and add needs to be before main. Yes, that makes sense. Yes, so as we saw here, you need a forward declaration for using add. We were actually on the something rule, if I remember correctly. Let's have a look at where we actually were. Yes, we were at the one definition rule. Okay, the one definition rule, I'll probably make a note of this. Let me just clear my terminal. The one definition rule. So the one definition rule has 3 parts. Within the file, each function, variable type, or template is a given scope, can only have one definition, i.e., this is a definition, so your add is the definition. Your definitions have scope, have different. Your definitions occurring in different scopes do not violate this rule. I.e., we learnt last time that our local variables or or was it local? Let me just, scopes, our local scopes, that was it. Our scope, our variables die or are terminated here. So therefore we can use X and Y in here. Yes, that makes sense. Within a program, each function or variable in a given scope can only have one definition. Yes. The rule exists because programs can have more than one file, which we'll cover in the next lesson. Functions and variables are not visible to the linker. Functions and variables not visible to the linker are excluded from this rule. So I would assume in something like Swift, when we're talking about MVM, model, view model, I assume they mean something like that. That's what I assume, something similar to that. But as we saw last time, we will have a look at that. Okay. We're still good? We're still good. Cool. Don't need to worry about that anymore. Types, templates, inline functions and inline variables are allowed to have duplicate functions in different files, so long as each definition is identical. We haven't covered what most of these things are yet, so don't worry about this for now. We'll bring it up when relevant. Okay, so what I'll do is I'll just copy that into our notes. So 1 within a program, 2 and then types. We'll get rid of that because it's not really relevant. Okay, violating part 1 of the ODR, i.e. The function, within a file, the function can only have one definition. We'll call a compiler issue. Violating this rule will cause a compiler issue. Violating part 2 will cause a linker issue. Now I believe the linker issue, the linker is the thing that joins them all together, i.e. the link between the various programs. Violating part 3, violating this rule will cause undefined behavior. So we have part 1 being the scopes, which will cause a compiler issue. Part 2, with only one definition, will cause a linker issue. Will cause a linker to issue a redefinition error. And then part 3 will cause an undefined. Here's an example of part 1, i.e. Within a file, each function, variable type or template in a given scope can only have one definition. Definition occurrence in different scopes do not violate this rule. So we can see here we have a return type of int and to the function of add, with the parameters of int x, int y, and we are returning x plus y. So this is then a violation because we have two definitions of add, i.e. being int y and int x and int y. And then again in main we're having another violation because we've already defined x. Yes. Okay, that makes sense, sort of. A function prototype is a declaration statement, i.e. This, that includes a function name, return type, parameter types, and optionally the parameter names. It does not include the function body, as you can see here. It tells the compiler about the existence of the function before it is defined. I want to make a note of that as well. So a function type, and then I'll do a e.g., and then we'll do, no, for example, the forward declaration, like this, and then I'll do that. A forward declaration is when you have a main function but the definition is done after the main function, something like that. A forward declaration tells the compiler, i.e. the main, that the identifier exists before it is actually defined. Yes. Okay. How do we declare forward declarations for functions? By putting it above the compiler, so that the main is the compiler. Let me just add that to my basics. The int main function is the compiler. I believe that I'm correct in that, in thinking that. Okay. Right. Nice. Yeah, we call it above the compiler. Okay. Write the function declaration for this function. Use the preferred form for with the names. So I assume he just means, so for example, if we got rid of all of this, and again, to practice, we want to remember to always include the library of, and there's just something on my keyboard. Okay. Include input output stream, and then well, just imagine that we have an int main, and that is calling std character out. I know it's not in the example, but I just want to get practice. The result is, and then you would obviously do math, or maths because I'm English, and then you would have the 4 functions there, and then you would have the line break here, and we would return 0 here. So underneath the main, let's put the return type of int do maths, and then we have an integer, the parameters of integer being first, another integer being second, another integer being third, and another integer being fourth. And then within this, we are returning first plus second times third divided by fourth. Because third is not spelled correctly. And then we're returning, so we don't need a return type. So then here, for example, if you did 1, 2, 3, 4, so we have enough modifiers, but this will not run. So what we need to do is to get a forward declaration, we need to call do maths via the forward declaration. So to do that, we would do basically the header, and we do not include the body. So we would do return type of do maths, and then we would need a semicolon at the end, and then we would do simply int first, int second, int third, and then int fourth. So I assume then that would allow us to produce a result. Yeah, so bod mass, bod divide. So you would do 3 divided by 4, which is 3/4, 0.75. Then you would times it by by 2, and then that would give you roughly 1. No, that would give you roughly 1 because we're making it integer, so we would round to the nearest whole number, and then you would then do plus 1, which 1 plus 1 is 2. Yeah, cool. And again, don't forget to include the semicolon. Nice. For each of the following programs, state whether they will fail to compile, fail to link, or compile and link successfully. Okay, let's give this a go. For the following program, so you have a forward declaration from int. You have are we still on the same one? Yeah. We have a forward declaration of add with the 2 parameters. We have a we have the actual definition here. Then we have the main, which is 3 plus 4 plus 5. But here we have 3 arguments rather than 4. So this will fail to compile. Good. This will fail to compile because we have 3 arguments, whereas in the parameter we have 2. Nice. And again we have add and add. This will fail to link. Doesn't compile. The compile will complain. Okay, this will not compile because, yes, that makes sense, because our add has 3 parameters, but our add forward declaration, which doesn't actually relate to this, so it's not really a forward declaration, I assume. So when we're calling in here, although we're referring to this, we're actually referring to here, so it won't compile. Whereas if we did int x, int y, int z in the arguments, we would compile. This is the opposite of that, where we have 3 parameters, but in the add forward declaration we only have 2 arguments. So this will not compile or link either. Doesn't link. The compiler will match. Okay, the compiler will match the forward declaration. Okay, let me make a note of this. So, as plain English as possible, if the compiler, aka int main, calls the forward declaration, then it will compile. But if the forward declaration does not match the definition, then it will not link. So you can have a file that compiles but does not link. Okay, and then such as this. Okay. So this one we have a forward definition of add with 3 arguments. Of 3 arguments, and then in the actual definition, forward declaration, in the actual definition we have 3 parameters, so that's all fine. So this should compile. This should compile even though the integers, the names don't match. Compiles and links, yeah. Yes, as we learned that in the previous lesson. This one, no parameter names, but we still have three parameters, and then in our definitions we still have three parameters. So this should compile and link. Yep. And then the final one, this will call this one and should compile and link because we have add with 3 arguments and we have the add here which is above the main, so we don't actually need this. Yeah, okay, cool. Programs with multiple code files. Nice, so that was an okay end to that lesson. As programs get larger. Okay, how are we looking? Yeah, we seem to be all good, still live. Okay, let's continue. Oh. Yeah, give them, so here I assume we'll be doing this, adding it here. So for Visual Studio users, go to the source files, add a new item, or instead of that, you can simply press this here, new file. So we'll do that, and then so it looks like he wants us to add CPP file for the original one we had. And then if we go to tasks, JSON. Sorry, that was Visual Studio, so that's not what I'm using. So I can actually skip this. But if you are using Visual Studio, I'd suggest you follow these instructions here. So for VSCode, as we just did, next open the task.json file. If you wish to be explicit when a file gets complicated, compile, replace file with each one of your name to compile. One line like this. Okay, I don't have a Windows or Unix. Although isn't Mac OS Unix? Is that the same, or am I just am I wrong on that? Well, the only way of, let's find out. Yes, Unix. So instead of calling each file by the name, which could make this JSON file very big as we include the number of files, let's try this. File direct name. And we'll replace that. Which might just be the same as that. But if not, we might just go back to this for now because it's a fairly simple one, or a fairly simple project that we're currently doing. So let's go back to our main and let's add the forward declaration, the compiler, i.e. main, and then the definition of add. So I'll do int main standard character output, the sum. And here we'll do the forward declaration. The forward declaration. So we'll do int add, and then we'll do int x, int y. Cool. So now we've got it back to where it originally was. So it says here that maybe perhaps we should move it to add, or its own add file, which we created just here. So what we'll do is we will go here, we'll remove add, and then we will put add here, and then as we originally had, we will then leave the forward declaration here. Forward declaration. And the app stays the same. So let's run it and see if that works. No, it doesn't. Okay. Show errors. And then we go to the terminal. So the issue is with this here. What if we did, instead of that, what if we did file directory name, and then we did file, just normal file? Would that work? Let me just clear. Let's have a go at that. No, that doesn't work either. No file directory name as main cpp pp. So is that because we need to get rid of cpp? possibly. Let's have a look. Again, we'll exit it. We'll clear just to make sure. We'll actually close the terminal and then run it again. No, so still shows the errors. No input files. No such as main CPP, but there is a main CPP. CLang error, no input files. I wonder why that is the case. Is it a IDE issue, or because I have a main CPP here, clearly. What about if it's just? What about if it's just file? What about if it's just file? Would that work? Although maybe it would just cause that. The thing is, you're doing it in... no, hang on. So we are in VSCode. So we need to come out of VSCode. Right? So does that mean we need to do file directory name, file base name with no extension? Now in JSON you would do something like this. You would do and that would make sure that you come out of the file. So we want to come out of the file. Learn CPP, main CPP. So what if you did that to come out of VSCode? Or would you do, because it seems you need to use stars, that. Let's give that a go, see if that works. If not, I think what I'll do is I'll just do that for now, and then off stream I will have a look and see the best way to deal with that. But then I don't think that would be right, because that's literally what I just did there. But with file, no, show errors. Bad substitution. So what if you kept file, you replaced file directory name and then the extension, file base name with no extension. What if you did that and then you did hash this asterisk 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 file.cpp. No, for a second I thought it worked then because it took longer, but clearly not. Linker command failed. Okay, so let's show errors. I think this might have to be something I look off stream, because the whole point of this is for me to learn C++. And I guess this is part of the issue. But I think for now what we'll do, or what I'll do, is I will move. Let me just try one more time. So we'll keep that. We'll get rid of that. And instead, what we'll do is we'll do this. And we'll get rid of that for now. And we'll replace it with that. And let's see if that works. So clear. And then we'll run. No, still doesn't. Because it's not recognizing main, it's not recognizing add, the add call. The linker command fail. Is that because, no, index. It's not something as stupid as that, is it? Space. No, it's not. Okay, so forget that. What we'll do is I'll definitely have a look at that off stream. So what I'll do now is I'll just go back to my JSON, task JSON, and I'll do what it says here. I'll be explicit. But obviously when the file gets bigger and bigger in different projects, it won't be exactly ideal. So for now, which again makes me think maybe I should look at a different IDE. So I might also have a look at that, another IDE afterwards, after the stream. So what we'll do is we'll make sure this compiles and runs and all that good stuff. We'll clear, we'll close the terminal, we'll save, and we've put in the explicit. Okay, and then it runs. So what I want to do is just briefly, I am going to make a note that first of all, if it works on another IDE, such as, if you've seen my other videos, you'll know that I've done videos on Swift, so on Xcode rather, so maybe the VSCode on Mac doesn't work very well. So look into other IDEs for C++, and then look into error for linker for multiple files in project. Because there must be a way around it. There has to be. I'm just probably missing it. Okay. I will definitely make a note of that. Yeah, I'll leave that here. Okay. Because while this is all good and everything, and actually compiles, Um, it's not ideal because we'll have to have, what if the file has thousands of C++ files? I mean, you'd have to keep going and going and going. So what we'll do is we will leave that for now, and I will have a look off stream. But we know it works now, at least for now. And perhaps I will move to, if it works on Xcode for future projects and actual projects, I might just move to Xcode. Yes. So yeah, that's the issue I'm getting. Make sure you've added add CPP to your project or compilation line properly. So you've added it to the project, yes. We don't actually need that file, do we? Because we never had that before, right? I'm pretty sure we never had that before. He says, maybe that was the issue. We had all these before. I know that. Okay, I will definitely have a look at that because that is annoying. And maybe I'll move to Xcode if Xcode works like that. So does that mean if you get a compile error about add, if you get a compile error about add not being defined in your main, you probably forgot the forward declaration. No, I haven't. If you get a linker error about add not being defined, I don't think that was the case. The most likely reason is that add is not added to your project, but it is. When you compile, you should see the compiler list both main CPP and add CPP. Solution Explorer. Is that this? You should, but we're in the Solution Explorer. What's this? The Explorer, yeah. if you see the main CPP, then the add definitely isn't getting compiled. So let's just go back to this. And then we'll do that. And let's see what the error is that we're getting. Clear this. We should get an error. Oh. Oh no. I thought, yeah, no, okay, don't worry. I thought it worked perfectly for a second. Let's add this back. Let's then copy that, but for these two. And let's see what error we get. No. Okay. I'll just leave it for now. And we will have a look at it off stream. Because there has to be a solution to this, surely. So we'll delete that. We will bring back our main and add. We'll delete all of this. We'll delete this. And then are we all good? We got the main. We got two mains. I think we had that before. Okay. Yes, I will definitely take a look at that off stream and get back to you on that, because I might just change the Xcode, to be honest. Maybe not for these lessons while I'm learning, but maybe during when I actually start creating real projects. So 2.8. So I'm just reminding myself to go back to lesson 2.8. Okay. Lesson 2.8. Okay, cool. I.e. this area, I'll just go over this area and see. I'll also try Xcode to see if that is an issue as well. So, split the following program into two main CPP and input CPP files. Main CPP should have the main function, input should have the get integer function. So what you would do, let's just do it actually. So originally you would have, this is the original code, I improve this. So we got return type of integer, we have the function name of get integer, and then we are giving a character output of enter an integer. Then we are defining the variable but it's uninitialized. Then we have a character input of entering the variable, and we are returning said variable. And then within our main, we then have an integer of x being initialized as get integer, and then we have a integer of y being initialized with get integer. All makes sense? So then we have a print of x with a string of plus, and then continuing with the exertion, we have y, and then another exertion operator. We have the string of is, and then we do the x plus y, and then a new line break. And then we return 0. So basically he wants us to move this into a new file and then make sure that main calls it back. So to do this, as per add, we will go to our Explorer. We will add a new file called, does he want us to name it? He wants to name it as input. So we'll name it as input.cpp. Then we will simply input the definition. You could copy and paste it, but I like to just get the syntax and how to code CPP in my head as much as possible. So int get integer. Sorry, I just saw something. Int get the integer. Int get integer, and then we have the print of enter an integer. We, as we know last time, we need to define character out. What do you mean? We have an int of x. We have a std character in of x, and we will be returning x. Std doesn't have a character out. Is that because we need to include IO stream? Possibly. But then our add, oh no, add just returned. Maybe if we did that, IO stream. Oh no, it is. Okay, good. So if, I believe that's what he said earlier, but I just forgot or misread it or went over it incorrectly. Each code that uses, yes, okay. Each code that uses C character out or C in needs include IO stream. Yes, so that was the reason why. So we've got our input. We'll then add our input CPP, and we'll just replace it with add. So input, and we don't need add anymore. So we can then get rid of this, and we can just declare the input declaration. And then we had No, sorry, get integer. Integer. And then semicolon. So we've moved it, we've moved the input, we've called it in the JSON, and then we've used a forward declaration to call it here. So that should run. So add an integer, 2 plus 3. So we should get 2 plus 3 is 5. Nice. Yes. Yes. Okay, cool. We'll go to the next lesson. Naming collisions and introducing namespaces. So what I'll do is I'll just take a mini break here and I will be back in just a second. Bye. Okay. And we're back. Okay. We're still good? We're still rolling? Yes, looks like it. Okay. Cominciamo. So, namespacing. Naming collisions and introduction to namespaces. Yes, that makes sense. So this is a naming collision or naming conflict. ACPP, we have a void function, and then we have a void function with int name2. When the compiles this program, it will compile A and main identically and compile with no problems. However, when the linker executes, it will link all the definitions of A CPP and main CPP together and discover a conflicting definitions for function myfunc. The linker will then abort with an error. Note this error often that this error occurs even though myfunc is never called. Most naming collisions occur in two cases. Two or more identically named functions or global variables are introduced in separate files belonging to the same program. This will result in a linker error as shown above. Two or more identically named functions or global variables are introduced in the same file. Okay, so it's just whether your function names are exactly the same. But remember, there's a difference between the forward declaration and then also the definition. As the programs get larger and larger and use more identifiers, the odds of naming collisions being introduced increases significantly. Yes. The good news is that C++ provides plenty of mechanism to avoid this. Local scope, which keeps local variables defined inside functions from conflicting with each other, is one such mechanism. But the local scope doesn't work for function names, so we need to keep function names from. So how do we keep them from conflicting? Scope regions. A scope region is an area of source code where all declared identifiers are considered distinct from names declared in other scopes. Okay. Two identifiers with the same name can be declared in separate scope regions without causing name conflict. However, within a given scope region, all identifiers must be unique. Okay, so you can, if you didn't have a scope region and you had the same name of myfunc, when it compiles and links, there will be an error. But if you have a region, i.e. a section where you have these functions, you can then name myfunc here and myfunc here in different regions. The body of a function is one example of a scope region. Two identically named identifiers can be defined in separate functions without issue. Because each function provides a separate scope region, there is no collision. Yes. However, if you define two identically defined named identifiers within the same function, like we saw earlier with int unassigned, int x unassigned, and int x5, the compiler will complain. I don't think so. Naming collisions. I won't copy all of it, such as the example. So I'll do this. We'll probably do this. And then we'll do scope regions. I'm sure if I keep practicing, then this scope region will become a lot more simple and I'll understand it a lot more better, as is always the case when it comes to coding. You just need to keep on practicing. Okay. Right. Namespaces. Namespaces provide another type of scope region called namespace scope that allow you to declare or define names inside of it for the purpose of disambiguation. The names declared in a namespace are isolated from the names declared in scopes, allowing for such names to exist without conflict. A name declared within a scope region, such as a namespace. Okay, a scope region, and I'm sure this will come clearer later, such as a name space. Is distinct from any identical name declared in another scope. For example, two functions with the identical declarations can be defined in different namespaces and no naming collision or ambiguity will occur. Namespaces may only contain declarations and definitions, variables and functions. Okay, makes sense. Executable statements are not allowed unless they are part of the definition within a function. Okay, that makes sense. A namespace may only contain declarations may only contain declarations, definitions. Executable statements are only allowed as part of the definition, which isn't that just the same thing as that? Namespaces are often used to group related identifiers in a large project to help ensure they don't inadvertently collide with other identifiers. For example, if you put your math function in a namespace with name math, your math functions won't collide with an identifying name function. Okay, that does sort of make more sense. Would be a bit helpful if we could do some projects instead. We'll talk about how to create your own namespace in a function in future lesson. Okay. Apologies. Right, back to it. In C++, any name that is not defined inside a class, function, or namespace is considered to be part of an implicitly defined namespace called global namespace, sometimes global scope. An example at the top of the lesson, functions main. The naming collision encountered in an example happens because both versions of myfunc ended in the global namespace yes, which violate the rules of it being unique. We will discuss in a later lesson. Identifiers declared inside global scope are in the scope of the point of declaration at the end of the file. Although variables can be defined in the global namespace, they should be generally avoided. To avoid. So, include input-output stream, imports the declaration for character output in the global space. All of the following identifiers are part of a global namespace. Void foo, int x, there's no initializer, int y, so they're all part of the global namespace, but this is the global scope. Okay. The std namespace. All identifiers in the C++ were available to be used without std prefix. They were part of the global namespace, i.e. here. However, this meant that any identifier in the standard library could be potential conflict. That is true. Code that was once working might suddenly have a naming conflict. Or worse, code that compiled under one version may not compile under the next. Okay. So character output is defined in the standard namespace. The name character output won't conflict with any objects or functions named character output that we create outside. Okay. When you use an identifier, that is defined inside a non-global namespace, such as the namespace std namespace, you need to tell the compiler that the identifier lives inside the namespace. There are a few different ways for this. Yes, so that's what we've been doing previously. We've been doing std character output used from the std namespace. The operator is called the scope resolution operator. Identifies the namespace. The namespace. Hang on, I'm just getting a call. I'll be back in a second. Apologies for that. Just a scam call. Right, let's get back to it. Okay. All right. Where were we? Namespaces. So that's the scope resolution operator. Identified to the name. Identifies the name space that is being used, and to the right is what is being assigned. So for example, when we use std character out, we are saying the character output that is declared from the namespace of std standard. Okay, that sort of makes sense. Okay, best practice: use explicit namespace prefixes to access identifiers with a to access identifiers defined in a namespace. I.e., if you do std character output, you should actually std character output. You should use the actual prefix, i.e., std. Using namespace std and y to avoid it. Another way to access identifiers included in the namespace is using directive statement. Here's our original hello world. Using directive. Okay. So we're by calling using namespace std, we don't actually need to use the scope resolution operator. Interesting. So for example, we could do this. I'll just get rid of input for now, and then we'll do so instead of doing this, which would semicolon, which would run we can do this. So using namespace std, then we can get rid of std character output, and that would still run. Yeah, okay. So it's using a directive. This is a bad way to practice and is discouraged by them. So our input-output stream imports the declaration of std character output in the global scheme. Then by calling the namespace, we make std character output accessible via just character output. I see, yeah. Because then if we then have a function with a return type of integer and the name of character output, it defines our character output as part of the global namespace. But then when we're in our main, which character output do we want? Yeah, exactly. Are we calling the namespace or the global namespace? Sure. Avoid using directives such as using namespace at the top of your program header. This violates reasons why. Okay. So we will add that. What I want to do. Okay. So it's not really bad. So the IO stream introduces the std character output, but then we then use the namespace. We use the std namespace to access character output, and therefore we can do it there. However, then if we did a function called character output, when we eventually call it in here, the main won't know what to call. That actually makes sense. So as far as I'm concerned for now, I will be going forward with that. Curly braces and indented code. in certain cases, identifiers defined outside the curly braces may be part of the scope. So, so we have the global scope here, imported via this. Then we have a we have a function with a return type of void with a parameter of int. Foo is defined in the global space. X is defined within the scope of foo. X, as we learned earlier, goes out of scope here after the curly braces. Yes. Then we have int, the scope region for the function main. Okay, I'm starting to get the hang of that now. So, global scope and scope region. So something such as is a declaration into the global scope. Then something like void foo int val, and then within there results in foo being defined in the global scope. Then within foo, within the foo braces, this is the scope region. So essentially anything within the scope, anything within the braces is created within the func region, and then goes out of scope, or as we learnt last time, is terminated when the braces end. And then, so anything within the braces are defined within the scope of a given function. That's how I would interpret it, which makes sense because that's what we did in previous lessons. So, for example, all exist within the global scope. And the statements, that does actually make sense now, statements in each function are in the scope region of said functions. Okay, that does make sense, yes. Okay. Introduction to preprocessor. How many have we got left on functions? Okay, so not much, not many. How long is this file? Not bad. Okay, I'll just take a tiny break and I'll be back in a second. Okay, let's continue. Introduction to the preprocessor. When you compile a project, you expect the compiler compiles each code for the file you've written exactly. This isn't the case. goes through pre-processing phase. In this phase, a program called the preprocessor makes various changes to the text of the code file. The preprocessor does not actually make... Okay. Most of what the preprocessor is fairly uninteresting. For example, it strips out comments and ensures each code file ends in a new line. However, the processor does have a very important rule. It processes, it is what processes includes directives, not derivatives, which we'll discuss more in a moment. When the preprocessor has finished processing the code, the result is called a translation unit. The translation unit is what is compiled by the compiler. Preprocessor directives, such as include. When the processor runs, it scans through the code from top to bottom looking for directives. Preprocessor directives, often called directives, are instructions that start with the hashtag symbol and end with a new line, i.e. the greater than symbol. These directives tell the preprocessor to perform certain text manipulation tasks. Note the preprocessor does not understand C++. Instead, the directives have their own syntax. The final output of the preprocessor contains no directives. So we have include, as we've already done with IOStream. When you include a file, the preprocessor replaces the include directive with the context included in the file. Consider this program. So we've got include input output stream. When the processor runs the program, the processor will replace include with the contents of the file named IOStream, and then processes the included content with the rest of the file. Since include is almost exclusively used to include header files, we'll discuss include in more detail in the next lesson. Each translation typically consists of a single code file and all headers. So before we start writing functions, we actually need to include the directives. Yes. A define directive can be used to create a macro in C. A macro is a rule that defines how input text is converted into replacement output. There are two basic types of macro, object-like and function. Function-like macros act like functions and serve a similar purpose. Their use is generally considered unsafe, and almost anything they can do can be done by a normal function. Object-like macros can be defined in one of two ways. Define identifier, substitution text. the identifier for the macro, I assume by that they mean the whole thing. In all uppercase, without separated by underscores. Object like macros with substitution texts. Consider the following program. When the processor encounters this directive, an association is made between the macro identifier. And a macro identifier is a rule that defines how input text is converted into replacement output text. So consider, the preprocessor encounters this directive. An association is made between the macro identifier and the substitution text. All further occurrences of the macro identifier outside the preprocessor commands are replaced by substitution text. So the substitution text is Alex in this case. So you got include, you got define a macro, define, which is a macro, creates a macro. Yeah. And then we have a substitution text of Alex, which therefore means that we can pass in Alex. And then, as we learnt there, the macro converts the replacement output, or replaces the text into an output text. So let's give that a go. So we'll include input output stream. We will then define my name and then the substitution text. Did I make a note of? Yes, I did. Define, and we have the identifier, and it's Alex. So then in our main, we have standard character output. My name is, and then we call my name macro. And then we return 0. So by using the macro like an object, we can then simply call, and we should get my name is Alex. Clear, run, and there we go. My name is Alex, and we were using the macro of define. With substitution text. I assume that means then you can do integers, possibly. or is it only just, no, it can't, we'll see later, I guess. How are we doing here? Yeah, seems to be still all good. Okay. Object-like macros with substitution text were used in C. They're no longer necessary as better methods are available. Okay. Avoid macros with substitution text unless no viable alternative exists. Okay, because it's probably best in C, and we'll learn that later, I assume. The best practice for macros with substitution text is to avoid said macros. For example, use yen. This might seem pretty useless. As it is useless for doing text substitution. However, this is not. That's not what this form of directive is generally used for. Unlike object macros with substitution text, macros of this form are generally considered acceptable to use. Conditional compilation. The conditional compilation preprocessor directives allow you to specify under what conditions something will or won't compile. There are quite a few different conditional compilation directives, but we'll only cover a few that are used most often. So, IF, DEF, IF or if, def, if, ndef, and if. Okay. So, if definition, if no definition, and end if. The IFDF allows to check whether an identifier has been previously defined via define. If so, the code between if def and end diff is compiled. If not, the code is ignored. Okay. So consider the following program. Include, we got the global scope. Global scope? Yeah, global scope. And then within the braces is the scope region. Yes, okay. Starting to get the hang of it. I can see why people say C++ has a steep learning curve. It certainly does. So let's again just practice and practice. IO stream. Then we are using the macro define print Joe, and then int main and then so the preprocessor of if def print Joe if def print Joe std, and then we print the character output of Joe with a line break. And then we end if. So this will only run if Joe has been defined, which he has in the header via the line define print Joe. Then we're using if def again. If def print Bob, and then the preprocessor of end if. Then we have the standard character output of Bob with a line break. If def, and as you can see, I don't know if it's visibly clear on my screen, but if you're following along, you can see here that the standard character output, this statement here, is blurred out compared to this. So this will not run /compile as print Bob has not been defined in our header. Cool, that makes sense. And then as always, we want to return 0. Whereas if we then decided we want to actually define print Bob, our print Bob comes back. So then if we comment out print Bob, it goes back to, I don't know what's the best way to describe that, faded maybe. So we'll clear that and we should just get Joe. There we go, Joe. Because print Joe has been defined in the line will be compiled. But print Bob has not been defined in the define macro. That's what they're called, right? Define directive. Define directive. Okay, so I did have a feeling. So if we did if not define, would that work? Yes, it would. Because, okay, let's definitely make a note of that. So the define directive has no. Allows for conditional compilation. And the standard, I know I'm repeating myself, but sometimes it's better to just write it in your own words. As the following standard, compilation directives. If def, meaning if the directive has been defined, end if end the directive, and then if n def, meaning if the directive has not been defined. Okay. Yes, and as we saw, since we didn't define Bob, we will now actually get Bob. So clear, and we should get Joe and Bob. And there we go, we get Joe and Bob. Okay, so you could just do that as well. So if 0. Another common one is if 0. To exclude a block of code as if it were inside a comment. So let's give that a go then. So we also have if 0, which acts, which makes the statements / lines of code behave as if they were in a comment. And this still needs to be ended in a end if. So let's give it a go. So include, again, input output stream, return type of main, return type of integer for a main function, standard character output, and we'll print Joe, and then a new line, a line break. So then we do if 0 std character output Bob, new line, and then std character output Steve. spelled correctly. And then we'll end if. So that should print Joe, but not Bob or Steve. Cool. Doesn't compile. Yeah. And as you can see, it's slightly blurred out, like it was with trying to define Bob. Oh, whoops. Cool. Yes, so the if zero preprocessor directive. The define preprocessor directive. Preprocessor directive. Preprocessor directive. Cool, nice. This provides a convenient way to comment out code that contains multiple lines of comments. That is true, yeah. To temporarily re-enable the code, we can change it to, okay. So preprocessor directive. Can change if 0 to if 1. Let's just check that that's actually the case. If 0, if 1. Cool, nice, and it becomes unblurred. We'll run the code and we should now get Joe, Bob, Steve. Joe, Bob, Steve, nice. Macro substitution within other preprocessor commands. Macro substitution. Now you might be wondering, given the following code, so we define Joe, if define Joe, print Joe. Yes, that should work fine, right? Since we define Joe to be nothing, how come the preprocessor didn't replace print Joe with if def print Joe with nothing to exclude? In most cases, but in most cases, macro substitution does not occur when a macro identifier is used within a preprocessor command. So we've defined foo as 9. If define foo, this foo does not get replaced with 9 because it's part of another preprocessor directive. No, okay, that makes sense. That because we're essentially in a way calling the macro. Directives are resolved before compilation from top to bottom on a file-by-file basis. Consider the following program. Void foo define my name is Alex. So we've defined foo, we've defined Alex, but surely we need to, surely it would be foo, not, but then void, foo is void. Even though it looks like define my name Alex is defined inside the instruction function foo, the processor doesn't understand C concepts like functions. Therefore, the program behaves identically to the one where define my Alex was defined. To avoid confusion, you generally want to define, but in an include directive replaces the include directive with the content of the included file. And include can copy directives from the included file to the current file. These directives will then be processed in order. For example, the following behaves identical to the prior. So does that actually run? Get out of here. Return 0. Does that actually run? So will it produce Alex? Yeah, my name is Alex. I'm a little bit confused, to be honest, on this one. So I will definitely make a note. On this. So the scope of defines. So copies define my name. Copies define Alex H. So where's... So is Alex H, is that a file name or what? So Alex, so H is C, C file. H is a C file. Include Alex H, and we're then including the C file Alex H into our file, and then there's a fly. There you go. Go on, buddy. Now I'm just going to let this fly out. Okay, I think he's out. Right. Once the preprocessor has finished, all defined identifiers from that file are discarded, much like you would have in the scope of a function. This means the directives are only valid from one point of the definition to the end of a file, like most things. Directives defined in one file do not have an impact on other files unless they are included into another file. Okay. For example, function CPP, so include, void, if defined print, printing, if not defined print, not printing. So this will print not printing because our print has not been defined here like it would. So then we get forward declaration and we define print. And because do something revolves around the macro of print, or the preprocessor of print, it will print not printing. So even though it wasn't defined, that doesn't have any impact on the function code. Sorry, the function CPP file. Print is only defined at the point of definition to the end of the main CPP. Okay. Header files. We also discussed how forward declarations are used to allow for code to access and define in another point. When programs contain only a few small files, manually adding a few declarations at the top of each file isn't too bad. However, as they get larger, having to add manually can be tedious. For example, a 5-file program, each of which required 10, would result in 50. Now consider the case where you have 100 files. Yeah, I can see that getting bad. I can definitely see that getting bad. Out you go. Hang on a minute. Okay. C++ code files. Yeah, I assume the H that we did with Alex H is what he's about to talk about. are not the only common are not the only files commonly seen. The other file type is called a header file. The header file uses the extension H, but you will occasionally see them with HPP extensions or no extension at all. So what I want to do now is we'll leave it still in functions, and now we'll do okay, yeah. So instead of doing, for example, calling the add or whatever, we can just put them with the declarations in, and we can save the countless forward declarations for our compiler main using standard library header files. Consider the following program. Include iostream hello world. This prints hello world. Yes, it does. I am just going to take a quick break here, and I'll be back in a second. Okay, cool, and we're back. All right, let's continue. Am I still live? Yeah. Okay, cool. And everything's working fine. Right. Time is 12:30, so we'll see where we get to. This seems header guards. So how many are we going to finish 2 today? Depends how long header files are. We'll see where we are at 1:15, and then we'll evaluate it there. Okay. Header files with the extension of H. Conventionally header files, yeah. So consider the following program. The program prints hello world, as we know. This program never provided a definition or declaration of std character output, so how does it know? Well, we get it from IOStream, as we know now. We are requesting that the processor we're requesting that they pre-process a copy of all content, including the declarations of character out, in the name IOStream. When you include a file, the content of the included file is inserted at the point of inclusion. This provides a useful way to pull declarations from another file. Yes, I understand that. Consider what would happen if IOStream didn't exist. Whether you used std character output, wherever you used it, you'd have to type out manually the declarations related to it. This would require a lot of knowledge about character output, and would be a ton of work. Even worse, if a function prototype was added or changed, you'd have to manually, so just use include IOStream. Using header files to propagate forward declarations. Now let's go back to our previous lesson. Like I mentioned, the add. So we've still got the add. Our main then needs to change. So we'll do, our main needs to change back, and our JSON task needs to change back to add. So we'll do the include IOStream library. We'll do the return type of int and add with the arguments of int y. We'll do the return type of int main and then we'll do what was it? std character output. The sum of 3 and 4 is, and then we do add 3 and 4, and then we line break, and then we don't have to, but we can return 0. And then that should run. We'll clear our terminal and we'll run it. 3 plus 4 is 7. Cool. If you're recreating this example first, we've already done. In this example, we use forward declarations so that the compiler knows. As previously mentioned, when adding forward declarations, manually adding forward declarations for every function you want can get quite tedious. True. Let's write a header file to relieve us from the burden. Writing a header file consists of 2 parts. So, writing a 2 T's or 1 T? Writing a header file has 2 parts. First one is a header guard, and then the second is the actual content of the header file, which should include the forward declarations for the identifiers we want to use in the other files. A header file, if you're using an IDE, go through the same steps as choose header source. If you're using a command line, just create a new file in your favorite editor. Best practice is to prefer the H suffix, unless your project already knows some of the conventions. Yes, okay. Header files are often paired with code files with header files are often paired with code files, with the header file providing the forward declaration and corresponding files. Since our header file will contain a forward declaration for functions defined in add_ccp, we will call our header add. Okay, that makes sense. Yes. So is if a header file, yeah. So let's add now. We'll get rid of input because we don't need it anymore. JSON we've already added. So now we'll do an add H. So here we'll do our forward declaration of int add int x int y, and then in order to use it, we then go back to our main. We can get rid of this, and then we need to include add H. And as you can see, the error now goes, and we should, when we clear the terminal, get 3 plus 4 is 7. Cool. So we didn't actually have to add H to our task JSON, which is useful. So this is where our header file, and is where we are putting our forward declarations. Declarations. We'll put a header guard later. When the preprocessor, so I believe that, and let me just double check, is include called a preprocessor? Yes, okay. So the include is a preprocessor. I'm just going to scroll up here, and then directive is When the preprocessor processes include line, include H, add H, it copies the content of add H into the file at that point. Because our add H contains a forward declaration for the function add, this, that forward declaration will be copied into main here, because we're calling it here. The end result is the program that is functionally the same as the one where we manually added the forward declaration here. And as you can see, that is a lot more cleaner code. Consequently, our program will link and compile correctly. So our add CPP, our main CCP has the preprocessor of include, add H, and include IOStream. Include add H relates to the adding header that compiles. That also links to the CCP that produces the object, which then creates a link, and then we get the standard runtime, and then we get the exe. Now the graphic component. That is a very useful graph or image. How including definitions into a header file results in a violation of one definition rule. For now, you should avoid putting functions or variables. So remember, a definition, this is a declaration. This is a definition and declaration. This is a declaration and a definition. Remember, the declaration is without a body, whereas a definition is with a body. The definition of add in the header file, don't do this. Yeah, don't do this. Main CPP, add H, and then add CCP. When the main is compiled, the add H will replace the context of add H and then compile. Therefore, the compiler will compile something that looks like this. From add H, contents of IOStream, main. This will compile fine when the compile adds CCP. So you want to, it seems, also for header files, do not, it is best practice to not include definitions in definitions, as this violates the one definition rule, ODR. So even though it will compile, It's just best practice not to. But maybe if we put the maybe if we were to put the header guard that we'll learn, I assume, in the next lesson, maybe that would fix it. Source files should include their paired header. Ah, that's what he means. Yes. So this is the source file, and then we'll include the add h. When the add CPP is compiled, the forward declaration will be copied into add CPP at the point of the include preprocessor. When the compiler reaches a definition double, it will note that the return types of the forward declaration and the definition don't match. Because the functions cannot differ by return type, oh no, hang on. That's because he's changed it, hasn't he? So he's actually changed the double to double whereas if we got rid of that, oh no. He didn't change the function name, he changed the return type to double. That makes sense. If we got rid of that, would it still... So include the header into the source file as well as best practice. Do not include CPP files. Although the precursor, okay, so I'll copy and paste that. For our notes, troubleshooting. Okay, what's the time now? Just around 1. We'll see where we are when we get to this. So, troubleshooting. If you get a compiler error indicating add h isn't found, make sure it's in your file. Well, you can see here in our Explorer, we have add h here. Depending on how you created and named it, it's possible. So we don't have any issue with there. So I'm going to move on from troubleshooting there. So angled brackets and double quotes. You're probably curious as to why. So the angle brackets, i.e. this here, is what he's referring to. So you got include IOStream in angle brackets, and you've got add H in double quotation marks. It's possible for the header with the same file name to exist with multiple directories. The use of our angled brackets gives us a preprocessor a clue as to what the file should look for. What it should look for in the header files. When using angle brackets, we're telling the processor that the header. Okay, so when we use when calling, or when calling the preprocessor, if we have not created it ourselves, we use angle brackets. But if we have created the header file, no, not header file, yeah, the header file, or directories, or directory ourself, then we will use quotations. Use double quotes to include header files you've written ourselves or expected to be found in a current directory. Use angle brackets to include headers that come with your compiler. Okay, that's useful. So we'll do that. We'll do this. And then we will just check. Okay, cool. Why does an IOStream have a H extension? The answer is H is a different file. So our C++ compatibility global namespace. So basically don't use IOStream H. Use standard library header use defined. Okay. Include header files from other directories, including header files. Another common question involves how include header files from other directories. One bad way to do that, for example, include my header files. I see what they mean. So, for example, this headers, my header H, would mean that you would have a directory called headers, and then you would have within that directory, like for example here in VSCode, you would write it as .vscode, and if you want to access the task JSON, you would then have task.json. again here, as I mentioned previously, if you want to go outside of the header or go outside of a file, you would use these two lines and then the path. While these compile, the downside of this approach is that it requires you to reflect the directory. If you have it, it won't update. A better method is to tell your compiler or IDE that you have a bunch of files in the same location so that it will look where it can within the current directory. This can generally be done by setting a include path or search directory in your IDE projects. For for VSCode users, in your task.json configuration file, in the arguments, the nice thing about this approach is you'll never change. If you ever change, yeah, that's another thing. I believe in Xcode you don't actually need that, but I will make a note of this if any issue comes up in the future. Which again is why I'm thinking of changing from VSCode to Xcode. Headers may include other headers. Okay, yeah, that makes sense. It is common for the content of a header file to have something that is declared or defined in another file. For example, if you're doing something in Swift, or you're doing something in JSON or JavaScript, or even Node.js, you can import and export various things. So the content of these transitive include, however, you should not rely on the contents of headers that include. Each file should explicitly include all header files it needs to compile. Do not rely on headers included transitively from other headers. Make a note of that. So for header files and includes, the best practice is that each file should explicitly include all other header files. Unfortunately, there's no easy way to detect. The order of inclusion of header files. It shouldn't matter. If header files are written properly and include everything they need, the order inclusion shouldn't matter. Now consider the following scenario. Let's say header A needs declaration from header B, but forgets to include it. In our code, if we include header B before header A, our code will still compile. This is because the compiler will compile all the declarations of B before A, because code runs sequentially when compiling and when running. Yes, that makes sense. Yes, however, if we include header A first, the compiler will complain because the code from A will be compiled before the compiler has seen declarations of B. Yeah, that makes sense. And let me just check something. Yeah. However, this is actually preferable because the error has surfaced and we can fix it. The best practice then is to maximize the chance of missing includes. Order your includes as follows, skipping any that are not relevant. The paired header for this, so that is the best way to for the order of inclusion of header files. The best outlay for order of inclusion of your header files is the following. The paired header file, i.e. in so the paired header file for this code, e.g., add should include add h. Third party, other headers from the same project. For example, mymath.h. That makes sense. And then you do third party headers. So you would do and then standard library. Okay. So to maximize, we'll just do that. The paired header. So first, second, third, and then fourth. Now, if you don't include, it won't necessarily break your code, but it's probably best practice just to do that. That way, if your user to find there's something missing and include, it is more likely to cause a compile error, so you can fix it. Cool. Header file best practices. So you want to, let me just check something. Header file best practices. Yeah, cool. Here are a few more recommendations. Always include a header guard. Do not define variables and functions in headers for now. Give header file the same name as the source, like add cpp, and the header file would be add h, so that way you can easily identify it. Or grades and grades. Each header file should have a specific job, and it should be independent as possible. Be mindful of headers you explicitly include for functionality for using your code to avoid inadvertent transitive includes. A header file should include any other headers containing functionality it needs, such as a header. Such a header should compile successfully when included in a CPP by itself, i.e. here. So you include the files in here in the header, and then you just need to run it once in CPP, your C++ file. Only include what you need. Don't include everything just because you can. Do not include CPP files in your headers. And then prefer putting documentation on what something does or how it does in the header. It's more likely to be seen documentation describing how such things work. Cool. So let's copy and paste that because that's really useful. And then I'll just indent this a bit. Cool, header guards. Right, what is the time? The time is 1:15. How big is this lesson? Fairly big. How are we doing? We're doing 3 hours at the moment. Let's go until 1:30, so another 15 minutes, and we'll see where we are. So now we're on header guards. Header guards. Okay. Yeah, we'll go for another 15 minutes probably, and then see where we end up. Because then after that we finish with functions, and we will move on to debugging the programs. And then you've got fundamental types, constants and strings, operators, and a whole bunch of other things. Classes, fixed, operator, virtual, input, output. Okay. So let's go back to header guards. We noted that the variable or function identifier can only have one definition. Yep. Thus, the program that defines the variable. Yeah, that's a compile error because we have already set up a definition for X. Similarly, programs that define function more than once will cause a compile error. Yes. So we got foo with a return value of integer, and this is the original definition. However, now we've defined it again, and that will create a duplicate definition, which will create an error. Integer of main, nice. So 10 more minutes, yeah. We'll just see how far we get in 10 minutes. while programs are easy to fix with header files, while these programs are easy to fix, remove the duplication definition with header files. With header files, it's quite easy to end up with a situation where a definition in a header file gets included more than once. This can happen when a header file includes another header file, which is common. So square h, we've defined something in a header file which we shouldn't do, and then wave h calls square h via include, and then so we've got square h, which is a definition, but wave h is calling it as well. So that will just create a duplication, won't it? Yeah, and it's just a duplication. Exactly. So, header guards. The good news is we can avoid duplication via header guard. Definitions that may occur with the use of a header guard. Header guards are conditional compilation directives that take the following form. So, if not define some unique name, define some unique name. Your declarations and certain types of definitions here. And then end if. So we'll copy and paste that because we're in the notes. So, when this header is included, the preprocessor will check whether some unique name has previously been defined in this translation unit. If it is the first time, yes, consequently it defines some unique name here, because if it's not defined, if not defined, we define it. If it is the first time we are included in the header some unique name, we will not have defined. So when the header is included, the preprocessor will check whether some unique name has previously been defined. If we're including it, it would not have been, for the first time, it would not have been defined. Therefore, it defines and includes the contents of the file. The header is included again in the same file. Yeah, so if it's not defined, we define it. All of your headers should have header guards on them. Some unique name can be whatever you want. Yeah, it's just okay. So you do, if not defined, then define it. But if it is defined, then use that. So here you would do square h, if not defined square h, define square h, and then get squares, and then you end if. Okay. So if square h is not defined, we would define square h here within square h header. Then we would have a return value of integer and the function of get square slides, and we return 4. And then we have end if. Even if the standard library header uses header guard, even the standard library headers use header guards. If you were to take a look at iostream, you would see, so let's have a look. Let's click on this, and there you can see, yeah, if not defined, this, define it. And then at the end we have end if for this. Okay, so that was the introduction to header guards. It's almost 1:30. I think we'll leave it here because there's quite a lot for header guards to go through. So we left off at, so what we'll do is, left off at lesson 2.12, updating our previous example with header guards. So now what we'll do is we'll save all our changes. So day 4, what did we do? The notes are probably the best thing to look at. Covered one definition rule, ODR. Covered pre-processor directives. Naming collisions. Scope regions. Scope regions as well as global scopes. Name inclusion, global namespace. Why to avoid using using namespace std because it can cause conflict. Global scope and global region, and scope region. More of a summary really. Then macros. Then conditional compilation, and then the scope of defines, and header files, and then finally we finished off with starting header guards. Guards spelled correctly. Okay. Tutto bene, and the date is the 1st of August 2026. Cool. Let's commit that. Nice. Let's close these. And yeah, hopefully if you followed along, you've found it interesting. It was a bit more difficult today, to be honest, with the whole global namespace and trying to figure all that out. Headers are interesting because they help you simplify your code as well. We also dealt with the file, and I'm going to take a look at, definitely, I've got a note here for the linker errors, to look into that, and maybe I will be using Xcode in the future when the projects start to get more complicated. Who knows, maybe when we finish header guards and we've moved on to debugging, maybe I will move on to Xcode there. But for now, we're on header guards and the importance of that, and the template that we use, i.e. if not defined and defined and then end if. If you followed along, tell me what you enjoyed, tell me what you didn't enjoy. If you want to see something different, or you saw something that I shouldn't have done, or you saw something that I should have done, let me know. And yeah, we'll see you in the next lesson. We have 2.2 in the next stream, 2.12. I'll see you in the next one. Please like, subscribe, comment, all that good stuff. And yeah, I'll see you in the next one.